So model context protocol. So before getting into who I am and what I'm going to present on model context protocol, let me start with a small history uh, to get you into this model context protocol world. So it all started with this particular era. Usually when I say history always dates back to, let's say, like 10 years back or 20 years back. But we are in GenAI world. Even 6 months is a history now. So let's start with the very beginning of it. This is where the AI machine learning world gave us a good large language model to these application developers. And one of the biggest challenges that time was it's prompt engineering. We have to keep on constantly saying that what it needs to pay attention while answering the questions. So we used to give XML tags or caps lock just to tell them, hey, pay high attention to this. And then came the next era where LLM models have been trained how to identify the context. So in this era, uh, the prompt engineering is more of like giving steps and tell them how to think through that steps. So we call it as chain of thought era. So here what we do is we give a bunch of steps, sequence of steps, what needs to be followed to do this task. And then we ask the LLM to do things step by step. And this also helps us to debug where it could have went wrong. And then that reasoning concept is also trained into LLM. So the LLM is good at reasoning. Now what we start giving as in prompt engineering is instead of just giving one step, like one solution, we started giving multiple solutions. And we ask LLM to pick the best solution for that particular context. And that's why we called tree of thought. So there what we do is we give a mini decision trees and let LLM pick which is the best decision it needs to do. And this came to the final stage, which is the current era, where we are in orchestration era. So what we do here is, here not only give the list of steps, we also tell LLM, hey, these are the people you can choose to get the answers for. So basically, we are giving them the tools. So orchestration era. So what we do here is we give a dependency graph. Hey, in order to do for this task, this tool is capable of this. If this task comes, escalate to this particular tool, get the context and answer for the end user. So that's the era we are in. Now, basically in prompt engineering, what we did in this current last 3-4 years, we made LLM how to think through chain of thought. And then through tree of thought, we made them to explore options. And then with orchestration, we made them to identify whom to call for that particular option. And now our LLM is ready for real world application and no more prompt engineering. We are entering the context engineering. When I say context engineering, the most important thing we need to understand to start understanding the context engineering is MCP, which is Model Context Protocol. Just to give a very overall simple example to relate and understand, think of a corporate environment where everyone comes from different culture, different groups, and different practices. They have different way to communicate, and the context might differ. So corporate, what they do is they set a protocol how to communicate and how to communicate with co-peers so that you can get the work done, iterate faster. So that is the idea of having a common protocol. So in this LLM world, the context can be coming from APIs, docs, feeds, a lot of things, right? And we need a common protocol. And that is where to communicate with LLM, Anthropic team came up with this open standard protocol. So in this model context protocol, what I'm going to do here today in this presentation is I'm going to share my experience or my learning curve, how I figured it out, what MCP does internally. And I'm Sanjay Krishna Anbalagan, a front-end engineer at Amazon. I did my doctorate from UMass Lowell. And let's start cracking. So in order to understand something, how it abstract, first we need to understand what is the current state of application. So from there, something is getting abstracted to evolve into the next state of application. So let's start with the action-based request response. So when I say action-based, current UI-based applications are action-based. Take this example. Here we have a dashboard where user can input the customer name and then add customer, which might do some mutation operation in the backend and then notify the front end, and then we can get the revenue, right? And that action layer is built on top of this data layer. So I have used Amazon icons here just to represent the individual pieces. So that's a gateway, purple color one. And the individual API endpoints, I'm using Lambda here. So one of the endpoint is add customer, another is get revenue. Now, to connect this action layer and data layer, this is where we application developers write code. So in this case, an action is getting triggered. And for that action, one logic we write here. So what are things we are doing here? First, we are identifying what is the action. And then we fetch the data from the backend or notify the backend for a task. And once the response comes back, we render it in the UI, right? Let's walk through. Here is a user typing charming chirrups in the dashboard and then clicks add customer. In our logic layer, this is the logic for creating customer. Here, what it does is it does a post operation. That means it's going to do a mutation operation in the backend. And the post operation is add customer. And what it does is once it adds the customer in the database, it's going to give us a response. And that response we are rendering to the front end saying that this is the company name, we are posting it here. And similarly, once the response comes back, user does a second action, in this case, get revenue. And this is the logic. And here we do call the particular URL to do the fetching logic. And here it communicates with the get revenue and then gets the data for us. Now the data is not a string. The response what we got is basically an object. So what we do is we do some post-processing of converting that backend data to match my UI data so that I can prepare a good UI out of it. So in this case, it's chat. Okay, now this is the current state of application. Now, if I want to abstract, let's start with the most easiest thing. Let's standardize the output first. So what do I have here? In the first action, I have a string which I converted into UI. In the second one, I have an object which I converted into UI. Now, the most easiest thing is just stringify the object and then put it in the front end. I know it's not a great UX, but just for the simplicity and make life easy for our understanding, I'm just rendering as it is. So we unified the output shape and we standardized that, right? Now, the next step is the tool routing. That's what we need to figure it out, what we can abstract out of the current state of application. And what do we have here? We have a if condition which matches with the URL. Basically, we are creating a key value pair for each action. Now, once I have a key value pair, I can have a util function. In this case, I'm just saying, hey, to get the data from the tool, this is the tool name and this is the tool input. Now get me the tool and make the fetch and give me the response. So it's straightforward, right? Now, our application code gets a lot easier, where all we just do is hard code the input for the particular action, but how to fetch and how to handle the response, that is kind of abstracted. Now, the tool which we are supposed to call to fetch the data, can we still need to stay in the application side? No, we can move to data provider. Whoever provides the data, they can actually take control of the tools they expose for us to access the data. And now if they do that, now my application code, what it does is just call that URL, get data from tool. And if you look at the input here, now input is fixed to access that URL, which is just the tool name and tool inputs, nothing else. Now, what if a data team exposes a new tool? In this case, it's get company info is a new tool they're exposing it. How does the front end even find out that? One of the easiest thing is if the data provider team expose all the tools which they have as an API for a front end layer to access it, that'd be great, right? So they can publish the list of tools. So now in front end, I can just access the list of tools and render a UI component or form component for that particular tools. So in this way, my action layer is completely decoupled from the data layer without worrying about list of tools provided to access that particular data. So what we have here, the logic layer and data layer combinedly become a tool layer for my application. So my application has to focus only on the tools without worrying about the underlying data this tool access it. So only thing I need to know is, hey, get the tools and get the data, right? Now that we abstracted the tool to the data provider team, and then the last one what we have remaining here is the tool input. How do I standardize that tool input? Okay, let's look what we have here. So for each set of tool action, when I say action, we have a hard-coded input here. Now, what do we have? We have 3 actions in the current application. One is add customer, get revenue, and get customer info. So what really we have here is a one-to-one mapping. Each action is mapped with the respective tool. Now, what if I combine all these actions into a single action? That means one-to-many mapping. That's possible. But how do I give actions? We need a way to give an actions, right? And that is where we are entering into prompt layer from action layer. Now, even though I give the action, I need someone's help. I think some service help to figure it out. Hey, this is the prompt. From this prompt, figure out the action and extract the input. And that is where LLM comes in picture for us. So we use the LLM's reasoning ability. We just talked about it. LLM has very good reasoning these days. Provided a good description, it can figure it out what is the tool and what are the inputs for that particular tool. If it is not there, it has the ability to ask the user back, hey, can you give me this information to process it? So LLM is good at very reasoning. So let's take advantage out of it. So what we're doing here is, using an LLM, we identify the action and extract the input. If LLM can do this from my application code, I can hand off this logic to the LLM. How? Like this, in my code, my job is just to ask LLM, hey, here is a user prompt. Now your job is to go and find me the tool and its respective input. And how it does, let's make a small code for this. Let's say, in this case, when user gives a prompt, the first task is to go and talk to the tool layer and get all the list of tools and give it back to the LLM. In the past, we had to give it to the UI layer to render different UIs. Now we are going to LLM. Why? Because LLM, based on the user question, will identify which is the right tool to get the right context for LLM to answer the question. So that's what's happening here. First, you ask LLM and gives the tool name and input. And once it tells us which tool, we call the respective tool layer, get the tool, and that will call the data underneath, get the data for us, and give it back as context for LLM. And LLM will answer the user question based on the prompt. And this is a 3-step process. And why can't we just share with everyone outside, right? Yes. So we don't have to repeat this code. Every team is writing the same code to communicate to LLM. So why do we have to write it? We can just have a library or some kind of a client we can expose for outside world, right? And that's what we have been doing now. Okay, let's walk through this. Now, my application code boils down to just 2 lines. One is just call the chat with the user question. That's enough. I'll start here. So here user is asking, can you add charming chirrups? And then it triggers it by calling the chat URL, which in case it has to get all the tools for LLM to identify what is the right action. So in this case, it gives all the tools to LLM, and LLM figures out the tool and tells the client, and client makes the call to the tool layer by giving the tool name and tool input to the get data function, which in turn calls the respective tool. In this case, it's add customer. It's a mutation process. It's going to do some kind of mutation and notify the invoker. So LLM has been notified, the customer is added. And now LLM gives that response back to the end user, which gets added here. The same thing happens for the next set of questions. So let's ask, can you give revenue of charming chirrups? So now what LLM is going to do here is, it is going to call get revenue in the data layer through the tool layer. Here, the response is going to be some kind of JSON, right? And those JSONs could be like a It's just a flat data. And LLM is smart enough to go through that and identify and do some summation and gives a conversation response. Here it gives revenue. Similarly, can you tell me what they are selling of? And this could be a data from static data, which could be a RAG. I'm not diving deep into what RAG is all about. It's more of like, think of like it's a bookish data. It just written somewhere. You just go to figure it out from all the RAG related contextual knowledge base. And that's where it gets this information and give it. Okay, now this looks cool, right? Now we have an architecture, no more coding, right? We just have 2 lines of coding. We abstracted everything out. Now, will this architecture work for any data layer? Right now, I just showed for customer, get revenue, get company info. Why not? It will work. Why? Because LLM is exposed only to the tool layer where it just has 2 API methods. Think of like 2 methods. One is get tools and get data. So it's up to the data provider team to give good description about their tools. When I say good description, it's not only tool description, it's tool input description and also tool output description. So that is the job of data layer, so that they can prepare a good tool layer on top of the data, which can be provided to this LLM. And that's it. And that's the MCP server which we are talking about. So if you are our data provider, if you want to be part of the LLM world, this is how you design your MCP server. Expose your tool list of tools and then implement this particular get data kind of functions that will take care of calling the respective tools. So this is possible because we standardize the input and standardize the output. And why the standardization becomes so easy? Because from LLM world, it's string in, string out. It doesn't care about any object structure because it's using its reasoning ability to understand from the object and give a string response. And that is the MCP server piece of it. And now how about LLM? So this LLM environment where the client communicates, that's we call it as MCP host. Because that takes care of responsibility of communicating with LLM with the different models, what you're choosing. It could be any model from ChatGPT or OpenAI or Anthropic Claude, or it could be Google's Gemini, or it could be from Facebook Llama or DeepSeek. So that kind of configuration, everything is set up to this MCP host, but we need someone to communicate, right? And that's the MCP client we just talked about. The whole job of the MCP client, it takes care of passing the context from the LLM, from the tools, tool providers and data providers, and passing to LLM. Now that we have this, how do you connect? In the examples what I show, I use REST API endpoint, right, to communicate it. So that's what you tell in your configuration, what kind of connection it is. In this case, it is going to be server-side events. But what if you want to run this locally in your laptop, so that you can communicate to all the locally run application in your machine? Yes, it's possible. As far as you said that transportation to standard IO, standard input output, it's possible. And also that application has to be part of the MCP server ecosystem by exposing all the application APIs through this protocol. Okay, now let's revisit the model context protocol naming here. So when I say model tries to be LLM, and the context is the data provider who provides the context. And how do you pass the context and how do you share the context is where protocol comes in picture. And that is what MCP's MCP team is providing for us. In this case, through server, we have 2 methods. So if your data provider has to be part of a context provider for LLM, implement these 2. And then part of the ecosystem. This is model context protocol. So what coding logic MCP server abstract? It's standardizing the tool output and standardizing the tool input and then abstracting the tool routing. Now, does this solve all the problem for us? Is it going to be like, wow, this is great. If I implement it, all my things are going to work? No. As I talked in the past, prompt engineering era is gone. Now we are entering into the context engineering era. Just to explain what is important from now on, I'll just put this small example here. If you look at here, this vendor public relation team is selling this fruit as fresh fruit, right? It's labeled as fresh fruit. That's a context. But in reality, the fruits are like 4 weeks or 5 weeks old. And LLM is never going to be aware of that, okay? And it's going to give the customer, in the name of fresh juice, a juice which is spoiled, and customer is not going to like it. The same thing happens here. So basically what you're going to do here is data and context has to be good. If you provide good data and context is not talking truth about the data, the reasoning is going to go bad. So if you want to give good reasoning, truthful context is very important. I wouldn't say good context, I would say truthful context. Your context is about your data has to be precisely correct. It helps LLM to do its job really well. And hope I gave quality context to you all today. And thank you, MLOps team, for providing this opportunity, sharing my context so that you can organize your mental model reasoning. Thank you, everyone. I'm open to take any questions now. Thank you. Okay, if you don't have any questions, I think thank you. Thanks everyone for joining my presentation. Hope everyone likes it. And thank you. Thanks for all.